Alright, this problem is going to be using gas law called Avogadro's law. This is our sample problem on slide 69 of our chapter 11 PowerPoint. Question states, a weather balloon with a volume of 44 liters is filled with 2 moles of helium. What is the final volume in liters if 3 moles of helium are added to give a total of 5 moles of helium? The pressure and temperature do not change. So our clue here that we're using Avogadro's law is that we're only dealing with a volume and a mole amount. So the equation for Avogadro's law is V1 over N1. In this case, lowercase n stands for moles. Don't ask me why chemists decided that, but n is equal to moles. V1 over N1 is equal to V2 over N2. So very similar setup to many of the previous worked problems. So we're going to go through and figure out what each of our variables are and determine what we need to solve for. So first number in our problem, 44 liters, that's a unit for volume. So our V1 is going to be 44 liters. And then it says it's filled with 2 moles of helium. So our N1 is going to be 2 moles. And then it says what is the final volume, so that's what we're looking for, when 3 moles of helium are added to give a total of 5 moles of helium. So you might be tempted to make N2 3 moles, but all it's saying is that we added 2 plus 3 to get a total of 5 moles of helium. And that total of 5 moles is what we're going to use for our N2. So now we have all our variables. We don't have any temperatures in this, so we do not have to change anything to Kelvin. We can just start plugging into our equation. So our first volume, 44 liters, over our first mole amount, which is 2, is equal to our V2, which is what we're looking for, over N2, which is 5 moles. We're going to cross multiply here and get 220 is equal to 2 moles times our V2. Now we divide both sides by 2. Divide that side by 2, and we get that our volume is 110 liters, keeping consistent with the unit of volume for our V1.